Hi, my name is Delaney Kirk, and this is Lab 1 for Physics 2211 about constant velocity. The purpose of this lab was to observe the motion of an object experiencing constant velocity without changing directions. This lab used two different models. First was Tracker for the analysis of the video, and then GlowScript was used as the computational model. These models were used to compare the change in position over time. The results revealed that the change in position over time had a positive linear relationship in both models, indicating that the object had constant velocity. The main physics concepts were Newton's second law, also known as the momentum principle. This relates the net interaction of the system with the surroundings to the observed motion of the system. Newton's second law states that F net is equal to the change in momentum over time. Momentum is equal to mass times velocity. If you take the derivative of this, you get F net is equal to mass times acceleration. Acceleration is the change in velocity over time. If an object experiences no change in velocity over time, then acceleration equals A. Consequently, acceleration equals 0. Consequently, mass times 0 equals 0. So a constant velocity, no acceleration, implies that F net equals 0, and therefore the object will remain in motion. To conduct the experiment, the purple expo marker was chosen as the system, and the table and earth were chosen as the surroundings. The marker moves from left to right, establishing a positive x-axis. The initial conditions chosen were a position of 0.13 meters in the x-axis and an initial velocity of 0.4242 meters per second. This is a video recorded that was then uploaded to Tracker to get the data, the analysis data. The image on the left shows how the axes were set up with a reference point of 0.1 meters. The pictures on the right indicate the graphs obtained from Tracker. This slide shows the code used in GlowScript, and there's a couple of important things to notice. First, the marker's position and velocity were set in lines 35 and 36, and then on the right side of the screen you'll see a while loop between 0 and 0.9 seconds, and in this while loop F net is set to 0, and then Newton's principle, the momentum principle and Newton's second law were updated in lines 59 and 60. The output of this computational model was the position time graph on the left with a positive linear slope, and then a velocity time graph that showed a constant velocity, as well as a text box with position and time data from that calculation loop. These were the data from both the Tracker and the GlowScript models. The Tracker data is on the left, and the GlowScript models data is on the right. These data points were overlaid onto a graph with the blue line indicating the Tracker analysis and the orange line indicating the GlowScript. They're about the same, both with the positive linear slope, except you should notice that the computational model has the expo marker reaching a further point than the Tracker does. And this was because a couple sources of error. First, the computational model did not account for other forces such as frictions, and use calculation where F net equals 0, creating those discrepancies. However, this is not true. In real life, there is friction. And additionally, there was position tracking error. It was very difficult to get the center of mass to be at the same point each time during Tracker analysis. And then we have the question, what if we switched the positive and negative axis? So in our data, the expo marker rolls from left to right, indicating a positive slope. However, if the positive and negative axes were interchanged, the slope of the graph would become negative. And then what does all this mean? Because the expo marker had that constant velocity, that indicates F net equals 0. This is in the y direction. The force normal from the table counteracts the force of gravity on the marker, And then in the x direction, the force from the push counteracts the force of friction. However, this is inaccurate, and the system does not have a net force of 0 in real life, and this is why there was those differences between the orange and the red line in our result graph. Thank you for listening.